Find all values of theta in the range of theta between 0 and 360 degrees, satisfying tan cos squared theta plus 3 cos theta equals 4 sine squared theta minus 2. Find all values of x in the range of x between 0 degrees and 180 degrees, satisfying sine 3x minus 21 degrees equals minus 0.809. Find all values of phi in the range of phi between 0 degrees and 360 degrees, satisfying cos phi minus 5 sine phi equals 0. So I've got the question here in summary form then. Let's have a look at it. So part A. This is going to be a quadratic in cos, isn't it, because of this term here. So we need to write the sine squared as 1 minus cos squared. So let's write down the equation then. Tan cos squared theta plus 3 cosine theta is equal to 4 sine squared we replace by 1 minus cos squared theta minus 2. So let's take all the cos squareds over here. We've got minus 4 come out here. Move that over, we get 14 cos squared theta. Then we've got 3 cos theta here. And then numbers wise, we've got a 4 here, minus 2 is 2. Move that over to minus 2. And there's nothing left on this side now, is there? So that's what we've got here. So now we can factorize, hopefully. Okay, so 7 and 2 I would presume it has to be. Hopefully. 7 and 2 and 2 and 1. And if we do that as a 1 and this is a 2, we'll get a difference of 3, won't we? 7 minus 4 is 3. So this would be plus, this would be minus, equals 0. So what have we got then here? The first one, we've got cos theta will equal, this would be 2 over 7, wouldn't it? And this one is cosine theta equals minus a half. So two possible solutions, let's look at them both. We're solving from 0 to 360, so we draw a circle and write cast. Cos is positive here and here, so we draw these two lines and we mark off the alpha to the horizontal. And we can then write cosine alpha and drop a negative if there is one to drop. Shift cos of 2/7, so let's do that in degrees mode. 2 divided by 7 equals 73.398 degrees. 73.398 degrees. So we can read off theta then. The first solution from 0 to 360 will be round to here, 73.398. The second solution will be right around to here, which is 360 minus 73.398, which is 280, 6.602. 360 take away the 73.398 basically. Tap it in the calculator if you need to. The next one then, again do cast. Cosine this time is negative, positive here and here, so it's negative there and there. Draw two lines, mark off alpha to the horizontal and write cosine alpha is equal to, and drop a negative if there is one to drop. So shift cos of half, cos of 60 degrees is a half, isn't it? So the first solution is round to here, 180 minus 60, which is 120 degrees, and the second solution is right around to here, 180 plus 60 is 240 degrees. So there's our solutions then for theta. So that's part A. Now we look at part B. We're doing x between 0 and 180. Okay, sine 3x minus 21 degrees is equal to minus 0.809. So part B, let's just write that down. 3x minus 21, wasn't it, degrees is equal to minus 0.809. Let's just check that. Yep, that's what we've got there. And there's our problem. Now we're solving between 0 and 180. Sine is negative, so let's draw our circle. I'm going to do a cast circle, even though I'm looking at 0 to 180. And here we've got sine is negative. Sine is positive here and here, so it's negative there and there. So x goes between 0 and 180, doesn't it? So 3x will be between 0 and 3x and 540. So that's why we're looking for the 3x in that range there. So basically we can go around it once more again. It's only going to be these two. So draw two lines and mark off alpha. And write sine alpha then is equal to 0.809. So alpha is shift sine 0.809. 53.998 degrees. 53.998 degrees. So our first solution will be round to here, won't it? Which is, so 3x minus 21 degrees will equal 180 plus 53, which is 233.998. And the other solution, 3x minus 21, is equal to, okay, so we go round to here, don't we? 360 minus the 53, so that's 306.002 degrees. So that tells us then that 3x is equal to 254, move the 21 over, 54.998 degrees, and also 3x is equal to, move the 21 over, 327.002 degrees. Now divide those by 3. 254.998 divided by 3. 84.999 degrees. X equals 84.999 degrees. And the other one, 327.002 divided by 3, which it should go in quite well. 109.001, isn't it? 109.001, I believe. 001, yeah, that's fine. And that's the 3dp. Okay, so there's our x values there for part 2. Yeah, that's B. And then part C, find phi between 0 and 360 such that cos phi minus 5 sin phi equals 0. So part C then, cosine phi minus 5 sin phi equals 0. So that tells us then, move that over, cos phi, move this across to equals 5 sin phi. Divide by cos phi, and that tells us, I'm reading from right to left, that tan phi is equal to, and I'm going to move the 5, so I've divided by cos, so I've got tan phi, and I'm also going to move the 5 down, so it's a fifth. So phi is equal to, okay, let's worry about this one now. Tan phi is equal to a fifth. We're solving in what range? Part C. 0 to 360. So let's draw a circle. CAST. Tan is positive here and here. Draw two lines. Mark off the alpha to the horizontal again. And simply write tan alpha is equal to a fifth. So that tells us that alpha, shift tan of 0.2, which is a fifth. Shift tan, 0.2, which is a fifth. 11.30310, isn't it, to 3dp? 11.310. So that tells us what the solutions are then here. Phi is equal to, we're going from 0 to 360, so the first solution is 11.310. And the other solution is right around to here. 180 plus 11.310 is 191.310 degrees. And there's our solution for phi.